Good morning, students, all of you. So, here today we are going to discuss about angle of banking. So, before going to that angle of banking, let us discuss first what is the advantages of friction and what is the disadvantages of friction, and also let us see how to reduce the friction. So let us see these three. Thereafter, we will discuss about the angle of banking. The first one is the advantages of friction. Without friction, we cannot hold this chalk piece or any object. For example, if I want to hold this duster, without friction, we cannot hold it. Suppose if there is no friction, means that this duster should slide down, it has to fall. But it is in our hand under some grip. This grip is nothing but due to the friction between the hand and this block. So we can say that this is an advantage, is that we can hold anything because of friction. And many more we can say such example. Example now, few more. Because of friction, one can climb the tree. The climbing of tree also because of friction only. And because of friction only, we can also lightening the matchsticks. Matchstick, if you light in, what will happen? It will get light. That is nothing but due to friction only. So due to friction, the lighting is to be produced. And also due to friction, we can walk. We are also walking because of the friction only. If suppose there is no friction, then we may skid while running, while playing, we may skid anywhere. But because of the friction between our feet and the road, we can run or we can walk. So this is the advantages of friction. And as well as because of friction only, the vehicles are safely moving on roads. If suppose there is no friction between the tires and the road, then there is a chance of skidding the vehicle. So the vehicles are moving smoothly means because of the friction between the tires and the road. And as well, applying a brake. While applying a brake, the brake also acting some friction on a tire, because of which the tires will stop. So that means application of brake also is nothing but due to the friction only. So these are the few examples we can say. So in this way, many more daily, there are so many applications we will do with the help of this friction. So these are some advantages of friction. Similarly, now let us see some disadvantages of friction. Disadvantages of friction means because of friction, the wear and tear of a machinery parts takes place. Wear and tear means in Hindi we'll say ghis jana. Suppose any two material, if you rub like this, what will happen? The material will keep on reducing their material, upper layer or upper whatever the molecules will be there, that will be keep on decreasing. That means wear and tear takes place. That is we call in Hindi घिस जाते हैं. ऐसा हम रब करें तो क्या होता है? वो घिस जाते हैं, मतलब ये मटेरियल कम हो जाता है. So that is called wear and tear. So due to the friction, wear and tear takes place of a machinery parts. That is one disadvantages. Second disadvantages we can say, because of the friction, heat is produced in a machinery parts. When continuously our machines are working, then what happens? Due to the friction, it gets heat up. This heat may damages the machinery parts also. Suppose some machinery parts are there. Due to the friction, what will happen? It gets heat up. This heat may damage the machinery parts also. So this is also one more disadvantages. Similarly, some more we can say. As we know that friction will act always opposite to that of the motion. Means what? If suppose this is body moving in this direction, body is moving in this direction means in opposite direction of friction is said to be acting. So to overcome this friction, I have to apply extra energy. If suppose no friction is there, simply it will move. Once I push, it will move. But because of the friction, I have to apply more and more energy. That means extra energy is required to overcome this frictional force. So this is also one disadvantage. I am continuously applying extra energy. So energy is supplied more. So this is one more disadvantages. And also, in this way, we can say many more disadvantages we can say. So these are all the disadvantages of the frictional force. So we have seen some advantages as well as we have seen some disadvantages also. So now let us talk about what how to reduce the friction. So friction between the two bodies, how to reduce it? Let us see. There are few methods are there to reduce the friction between the two bodies. One is by polishing method. Number one, we can say what? Polishing method means if you apply some polish on the surface, then it will become smooth. That means the friction is said to be reduced. So the first point is by applying some polish. That means first we can say that by polishing the rough surface, we can reduce the friction. That is the first point. Second point, by applying lubricant also. Lubricant means what? Like oil, grease, any oily item or oily substance. If you apply on a rough surface, then it will skid or it will move. Okay, so that means what we can say here, the friction can be reduced by applying some grease or oil, which we commonly call it as a lubricants. So by applying some lubricants also, we can reduce the friction of a surface. So this is the second point. Third point, by using ball bearing. By using ball bearing also, we can reduce the friction. Suppose say this body is moving on this surface. It is feel very difficult to move. Why? Because it is having so much friction. So it is not able to move. Okay. So what I will do is instead of moving like this, I will keep here some ball bearings. Ball bearings means what? See in the diagram. So this is we have seen like this. Now see, this block is attached to this ball bearing. Ball bearing is this is called ball bearing. Two spherical rings like it will be there. Okay, in that one ball, some balls will be there such that we have seen many times this one. So it will rotate about this ring. So these are called ball bearings. Okay. So instead of suppose if I take directly one block, if I push on it, then the block may feel difficult to move. Instead of this, if I attach these two ball bearings to this block, if I apply these two ball bearing, then if I push it, then it will move easily. So by using this ball bearing also, we can reduce the friction also. So this is the third one. So first one, what I said, first one is applying a polish to the friction surface, and second one is by using lubricant to the frictional surface, and third one is what? Apply a ball bearing. Means if you place a ball bearing, if you attach a ball bearing to the substance, then it will move easily. So in this way we can reduce. And also by using streamline, by streamlining the bodies, by using streamline. What is streamline? Let us see here. Let us see here what is streamlining. Suppose say the shape of a vehicle is made in such a way that the front part will be like a pointed one. So in this case, what happened when the vehicle is moving in forward direction, then air is said to be moving in opposite direction. So when when the air is moving in this direction, again this vehicle has to move. So during that time, no air resistance should be act on it. That means friction due to this air should be reduced. So for that purpose, what we will do is the shape of the vehicle is made in such a way that the front part is made to be like this pointed in this way, or it may be sometime like this also. So if you make the front part as like a pointed one, example we can see like a rocket or aeroplanes, and also in a nature we have seen like a birds or fish in a water. So fish in a water has to overcome the frictional force by the water. So water, it has to overcome the friction due to the water and it has to move forward. So in that case, if the front face is not at all, suppose front face is not a pointed one, suppose if it is a flatted one, then then the water resistance will be more for the fish and it cannot move easily in a forward direction. To reduce that water friction, then the front face of that aquatic animals are almost, they have made like a pointed one, like a fish. It is made like a pointed one so that it can easily move in a forward direction. So that designing of that particular front face, that is called streamlining. So here, any vehicle or any aquatic animal or any bird, there, that is designed in such a manner that the front part of that particular object is made a pointed one, so that to reduce the frictional force, so that it can easily, it will move. So this designing is called streamlining, we can say. Okay, so by using streamlining also we can reduce the friction. So this is one more. This is fourth one. Now last one. By maintaining the cushion of air between the two solid bodies. Suppose say two solid bodies are there. If two solid bodies are there, suppose some missionary part, two solid bodies are there. If they are in contact, means what will happen if they are moving like this, suppose, then what will happen? After some time, wear and tear takes place. Okay, so to reduce that friction, to reduce the friction between these two bodies, a bag, that is air bag, suppose if you place between these two, then what will happen? Now it will run, suppose like this. Then what will happen? In between these two solids, here the air bag will act as a, it will act such that to reduce the friction. That means here the cushion of air, between the two solid bodies will act as a reducing of friction. So in this way, we can say that these are the few methods to reduce the friction between the any two objects. Okay. So now the important topic, that is called angle of banking. Let us see that. So what is angle of banking? What is angle of banking means? To know this one, angle of banking, let us have a small example, then I will go further. Angle of banking means, as we know that whenever we move in a road, if you move in a straight road, that straight road is nothing but we call it as a level road. Level road means it will be in a straight. Suppose if you move on a road such that if a road is a curved one, then in a curved surface, then how it will be means, especially we can see in a hilly area or hilly region, in that case we can see that the roads are little raised, one side it will be raised in this manner. In this manner, the road is said to be lifted up on a hilly area. Why? Because in the hilly area, in a top of that, if suppose the road is not lifted up, means the speed of the when a vehicle is coming with a speed, then there is a chance of that vehicle to skid outside. Okay, then the vehicle can skid outside, he can go out of this track. So to not to fall outside, to provide an inward direction, a centrifugal force is said to be acting. to provide a centripetal force. Centripetal force means what? The force has to be act on that vehicle towards the inward direction. So for that purpose, the road is to be lift up little. It will be not like a level. Level means straight. Okay, level means what? We can say that is straight. If the road is lifted one side, that means outer edge is lifted, then this is called banking of road. So banking of road is nothing but level road is there. So if you lift the road in one side, then we can say that this phenomenon is called, this is called banking of road. That is called banking of road. So what is banking of road mean? The outer edge of a road is to be lifted up so that to provide a necessary centripetal force so that the body should not skid outside. He will be safely moving on the road. So this is made in generally in the region of a hilly region where the sharp turn is there. Where the sharp matlab immediate turn is there. There they will provide more banking. So banking is nothing but one side the road has to be lifted by making some angle theta with the level road. So that angle is called angle of banking. That angle is called angle of banking. Let us derive that one. So let us derive the next one. Let us see this. So this question is very important one. Many times they used to ask. Let us see what they will ask, how the question will be. Let us first I will write the question here. So here, the question is, derive an expression for a maximum safe speed of a vehicle on a banked road in a circular road or in a circular path. Circular path. So that means when a vehicle is moving in a curved path, that is when a vehicle is moving in a curved path, that is if you consider on a hilly region, there what will happen is one side they will lift up. As I told you, the outer edge of a road will be lifted up so that to provide a necessary centripetal force. Okay, let us draw the diagram. Suppose say this is a curved road. This line represents what? This is called level road. Now, this level road, if the car is moving directly like this, then if this is level road, if car is moving in a very faster in the level road, then when it is making some turn, then what will happen? The body will or the vehicle will skid off. The vehicle will be skid off. So that to not to skid the vehicle, the road has to be lifted up. So let us say the road is lifted to this much angle by an angle theta. This angle is called angle of banking. So that means the level of the road which is there, it have been lifted up. Now the road is like this. Initially road is like this. Now the road have been like this. Now the road will be like this. Okay. So now in this case what happened is Suppose say this is a vehicle of mass m. Its weight is acting in a downward direction. Say that is mg, and it is having a reaction, that is a normal reaction will be in this direction. Okay, and this vehicle is moving like this means, that means in this direction it is moving means in towards the road, that is inward direction. A frictional force is said to be acting. Okay, a frictional force is said to be acting. Therefore, this frictional force can be split up into two components. One is in this direction and one is in this direction. Say if this is angle theta means I can say this is also angle theta. So friction is making an angle theta with this. So this side we can call it as a Fs cos theta, with which it is making angle theta, that is called Fs cos theta. Another its component will be in downward direction, that is Fs sin theta. So here friction on a road is split up into two components. One is called Fs cos theta, one is vertically down Fs sin theta. Similarly, this is called normal reaction. Here, normal reaction also split up into two components. One is in this direction and one is in upward direction. So, from the geometry, if this is angle theta means this is also angle theta. Therefore, with which it is making angle theta, just now I told, with which it is making angle theta, this side it will be cos. So here also with which it is making an angle theta, this side it will be n cos theta. And another component here, it will be its component here, n sin theta. So here, as the vehicle is moving in a curved path, during that time, on this vehicle, a centrifugal force is said to be acting toward the center, so that it should not skip up. It should not skid outside. So one centrifugal force is acting on this vehicle to keep on the road. So inward one force is said to be acting. That force is called centrifugal force. So that centrifugal force expression is nothing but, here it is given Fs cos theta and here n sin theta. So sum of these two will be providing as a centrifugal force to keep the body on that place only, not to skid outside. So let us say this vehicle is moving in this direction, means on a road with a velocity v. Let us say somewhere here the road center will be there, which is like a curve. Let us say this is the center point. From the center to this vehicle, let us say the distance is, say, that is r I have taken. Okay, so from here, from this diagram, let us say this car is moving with a maximum speed. Let us say the vehicle is moving with a maximum speed without skidding. So for that maximum speed, that only we are going to derive the expression. This is called safe speed, maximum safe speed of a vehicle. Let us say V max is the maximum safe speed with which this vehicle is moving. So now at equilibrium condition, these two are equal. See, here in upward direction, normal reaction is there, that is n cos theta. In downward direction, the sum of these two are there. So these two are get balanced. So I can say that here n cos theta is equals to this one, that is Fs sin theta plus mg. So this how these two have been balanced. So from this I can say mg is equals to I will bring this side, that means n cos theta minus Fs sin theta. Say this as equation 1. So now these two I have taken. Now here one more thing is there. So towards the center, see Fs cos theta plus n sin theta also acting, which is nothing but equal to the centrifugal force. So the sum of these two will act as a centrifugal force. So I will write that word here. Here Fs cos theta plus n sin theta will act as centrifugal force. That means the sum of these two is nothing but centrifugal force. We know that a centrifugal force formula mv square by r, mv square by r. So which is given by centrifugal force is mv max square by r. Here m is nothing but mass of the vehicle, v max means with which it is moving, r is nothing but center, the distance between the vehicle and the center. This is called r. So this is mv square by r, which is nothing but equals to the sum of these two, that is fs cos theta plus n sin theta. Say this as equation 2. Now what I will do is I will divide these two equations to get V max square. We have to calculate here maximum speed of a vehicle. To get this V maximum, we have to divide these two equations. Let us say equation 2 divided by equation 1. If I divide these two, this is mv max square by r whole divided by mg is equals to this one, fs cos theta plus n sin theta whole divided by n cos theta minus f sin theta. So here m will get cancelled. Therefore, what is left here? V max square divided by this r with this term will come down. Means I can write here rg, which is equals to, we are getting this again, that is fs cos theta minus n sin theta divided by n cos theta minus fs sin theta. So here what I will do is here dividing above equation with, I will divide above equation with n cos theta. If I divide the above equation with if I divide this numerator as well as denominator, both if I divide with n cos theta, divide numerator and denominator with n cos theta. That means V max square by Rg is equals to, numerator means this one, that is fs cos theta divided by n cos theta minus n sin theta divided by n cos theta whole divided by, now dividing denominator with n cos theta, that is n cos theta divided by n cos theta minus fs sin theta divided by n cos theta. So therefore, if you see here, cos theta will get cancelled, n will get cancelled, n cos theta also getting cancelled. Therefore, what is left here? Here, what is left here? fs by n. This is fs by n. We are getting this minus here. Sin by cos is left, means I can say tan theta divided by, here everything is cancelled, means 1 minus here fs by n sin by cos is tan theta. So therefore we are getting this one. This is V max square by Rg. So if you see here, since we know that fs is equals to, mu s into n. Since we know that fs is equals to mu s into n, therefore mu s is equals to, I can write what? Fs by n. So wherever Fs by n is there, I am write mu s. Means this will become mu s. This also mu s. Means here we can write V square max by Rg is equals to, this will be mu s minus tan theta divided by 1 minus, this will again mu s tan theta. So this will be plus, no? This will be plus. Therefore, now this Rg will go there. If it is going there, means I will write like this only. This I can cross multiply there. That means I can take this Rg here. Rg is going there. Therefore, what is V max square? V max square is equal to this much. V max is how much? We have to apply the root. So therefore, root of Rg into mu s plus tan theta by 1 minus mu s tan theta. So this is the expression for maximum safe speed of a vehicle, so that it can move without skid from the road by making an angle this much. If the road is making an angle this much, that is banking angle is this much, and if the coefficient of friction between the tire and the road is, if you provided this much, then we can go this much of maximum speed. So they may ask the question like this: derive the expression for a maximum speed of a vehicle on a banked road in a curved path. Then what is the maximum speed it can move with? This is the derivation. So this is the answer we have to do. So maximum safe speed is this much. Okay. Here are some cases we can see. Case 1, suppose. Case 1 means for a level curved road. For a level curved road, see, when a curved road is very sharp one, means immediate sharp is there, immediate curve is there, then the banking has to be increased more. That means angle of banking is to be rise more angle. Okay. But here the question is, in a case 1, for a level curved road. For a level curved road means what? Level curved road means what? When it will take place means if the road is of curved only, but it is not a sharp curve. The road is still somewhere it is moving like this. So for this much of curve, we no need to provide a bank. Level road also no problem for this. If the road is immediate curve, for that we have to make some banking angle. So during this time we is telling, so for this a level curved road is what? Level curved road is what? There is no banking of angle. So here banking of angle is not there. That means road is only straight, but it is curved one is telling. Okay, so for this level road means for a level road, angle of banking, that is theta, is 0 degree. That is theta is how much? 0 degree. Then from that equation, what is the maximum speed now? For this, what is the maximum speed? So substitute this 0 value here. If you substitute here 0, this will become 0. This one also will become 0. What is left here? We will left with root of Rg into mu s is left. Here tan theta 0, here also tan theta 0. Only here 1 is left, here mu s is left. So finally root of Rg into mu s is left. So we will get from that equation we will get root of Rg into mu s. So this is the maximum speed of a vehicle on a level curved road. on a level curved road. So this is the maximum safe speed we can say. Got it? Second case, case 2. For a now second case is banked road without friction or frictionless road. Frictionless road with banking. That means angle is there, but the friction is zero is telling. No friction is there. Then what we have to do? So for frictionless road, mu s should be 0. Why? Because no friction is telling. Without friction, any frictionless road, that means mu s is equals to 0. So if you put the mu s is equal to 0, then from this value, from this formula, we can write V max is equals to this mu s is 0. Here also mu s is 0. Mu s 0 means this entire term will become 0. Here 1 is left. Here this is also 0. What is here left means tan theta is left as well as Rg is left. So if I multiply with this, then we will get here. Here we will get root of Rg and theta. So this is bank of road. Some angle is there. Banking of road, but frictionless for this. This is banking of road with friction. This is banking of road without friction. This is level road with friction. In this case, suppose no friction is also involved there, with this velocity should be 0. Okay, so these are the two cases with this, which is very important for this. Okay, right. Now let us go for some problems. Okay. Basing on this chapter, basing on this laws of motion, let us go for some problems. See here, a question is given. I will write the question. Problems. A constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meters per second. How long does the body take to stop? So here the question is asking, a constant retarding force of 50 Newton is applied to a body. See here, what is given here? First we will write given data. What is given data there? Retarding force F is equals to 50 Newton. So retarding force means what? Opposing force. The body is moving in this direction. In this direction, the force is said to be acting. That force is called retarding force. So I will take it as a minus. Retarding force means opposite force, so minus I will take. So therefore, next is given what? Mass is given. Retarding force is acting on a body of mass, that is 20 kg is given. Moving with initial velocity or initial speed of, that means initial speed is 15 meter per second. This is given, and is asking how long does the body takes to stop. Take to stop means finally it is coming to rest. Means final velocity indirectly is given 0, came to rest. Now how long does it body takes to stop? Means he's asking time is how much. How much time it will take to stop? He is asking that is question. So here, here one body is there of mass m. It is initially moving with the velocity u is equals to 15 meter per second. This is given. Here mass is 20 kg given. He is telling that in opposite direction, a force F is said to be acting, which is equals to minus 50 Newton. So this is in opposite direction. That's why F I have taken as minus. So now he's telling the body is moving in this direction. Somewhere it came. Suppose say the body after reaching to this point, it came to rest. That means he's telling when the body will stop, he's telling. So let us say here it is stop. So final velocity is 0. So here we know that F is equals to given how much? Minus 50 Newton is given. Since we know one formula, what is that? F is equals to ma. According to Newton's second law, F is equals to ma, which is equals to minus 50. Therefore, A is equals to minus 50 by m. Therefore, minus 50 by m. What is m is here? 20 kg. So 20 kg. So these two will get cancelled. Therefore, A is equals to how much? Minus of 2.5 meter per second square. So this is the acceleration with which this body is moving toward that side with this much of acceleration. Now he's asking what is the time taken is asking. So therefore, since we know that one formula, that is the equation of motion formula, that is V is equals to U plus AT, one formula is there. We know this formula, and here since final velocity V is 0, initial velocity he has given how much, that is 15 meter per second, and A already we got how much, that is minus 2.5 meter per second square. Now substitute these values here. So 0 is equals to 15 plus this will become minus of 2.5 into t. This will come here 15. It will come here with minus 15 is equals to 2 minus 2.5 t. Minus minus will get cancelled. Therefore t is equals to, I can write 15 by 2.5. So 15 by 2.5 means we can say that this can cancel by 6 times. So we can say t is equal to 6 seconds. So t is equal to 6 second time. So the body takes the time, that is 6 seconds. After 6 seconds, the body came to stop. Okay. So now go for the second one. Next problem. Second problem. A body of mass 5 kg is acted upon by two forces, that is 8 Newton and 6 Newton. Full stop. Give the magnitude and direction of the force, not force, acceleration of the body. So this is the question. So here again, what is the given data? First write down the given data. Given data, what is given? A body of mass is given how much? 5 kg. Two forces are there. Let us say one is along x-axis, say that is 8 Newton. Say one is along y-axis, say that is 6 Newton. So here one more thing is left, that is a body of mass 5 kg acted upon by two perpendicular forces. This is perpendicular forces. Perpendicular forces. That's why I have taken one is Fx, one is Fy. Means along x-axis, along y-axis. Two perpendicular forces given. What is the acceleration is how much of this body, and also is asking the direction of this acceleration is asking. Very simple. See, from this is a body of mass m. So it's telling that two perpendicular forces are acting. One is 8 and one is 6. That is, one is Fx, Fy. Say in this direction, Fx is equals to 8 Newton is acting. In this direction, say that is Fy, which is equals to 6 Newton is acting. The resultant of these two will be somewhere it is acting in between these two somewhere. So from this, if I draw one more line like this, if this is Fy, this is also Fy is equal to 6 Newton because these two are parallel. So now say the resultant of this Fx and Fy, say this is the resultant. That is, say that is F. So from this right angle triangle, I can say F is equals to root of Fx square plus Fy square. Fx means what here? 8 square plus Fy means what here? 6 square. So therefore, this one 8 square means how much? 64. This is 36. So this will become how much? 60, 100 it will become. So therefore, F is equals to root of 100 is 10 Newton. So this much of force is acting on it. So this much of resultant force acting. But he is asking what is the magnitude and direction of acceleration he is asking. So to calculate acceleration, since we know that F is equals to ma, therefore A is equals to, we can write F by m. Therefore F is how much? Just now we got, that is 10. M is how much mass is given. How much that is? 5 kg. So 5. So therefore 2 meter per second square. So acceleration is equal to 2 meter per second square. So the body will move in this direction with an acceleration of this much. That is 2 meter per second square. Okay. So therefore, what is the direction of this acceleration? Means, let us say it is making an angle, say that is theta. So here theta gives the, that means the theta means here the angle gives the direction. If it is 45, it will show like this. If it is 90 degree, that means its direction will be in this direction, upward. If it is 0 degree, means like this. So the angle represents the direction of this acceleration or this force. So here angle represents the direction, whether it is moving 35 degree, 30 degree or 45 or 90 degree or 0 degree. So this angle represents the direction of force and as well as acceleration. So to calculate this angle, that means the direction means we have to calculate the angle. So for the direction, we have to take here the component we know Fx, Fy as well as Fx. These two terms we know. So we can take here tan theta we can take. If you take tan theta is equal to Fy by Fx, perpendicular by base. that is Fy by Fx. What is here? Fy means what? 6 by 8. So therefore, tan theta is equal to 6 by 8. Therefore, this can be written as 0.75. Therefore, tan theta is equal to 0.75. Therefore, theta is equal to tan inverse of 0.75. So this is the direction. So to see this, this tan inverse way to see means we are having a logarithm book. In that logarithm book, we have to see a natural tangent. One table will be there, where natural tangent will be there. In the table, we have to see that under this 0.75, what is the angle is there. We have to see that value for this respective value. What is the angle we have to see there? If you see, there we will get in the table, we will get natural tangent. If you logarithm book, if you see, in that you will get the answer will be, you will get 36.87 degree. That means the answer will be 36.87. So to see this tangent, or not only tan, to see cos, sine, tan, any such trigonometric function, if you want to see, we have to see the logarithm book. We have to use the logarithm book. In that logarithm book, for given value, tan of suppose 35 degree, how much for that its value will be there. So that table book we have to purchase and we have to see that one. Okay. So from that we can see, if you see this value, you will get this much of angle. Clear? So this is the direction. That means it is making how much angle means theta is equal to 36.87 degree. So that much of angle the acceleration is. That is the direction. Now come to the point, next problem. Two bodies of masses 10 kg and 20 kg kept on a smooth horizontal surface are tied to the ends of a light string. A horizontal force F is equals to 600 Newton is applied to number 1 A, number 2 B along the direction of string. What is the tension in the string in each case? So see here, what is asking is So here in this question is telling two bodies of mass 10 kg and 20 kg are kept on a smooth horizontal surface. That means here a smooth horizontal surface I will take. Say this is the smooth horizontal surface. One is, say this is a mass A and say this is a mass B. Two bodies are there. One is, say this is A body of mass 10 kg and one more is telling, say this is little bigger one, say this is of B of 20 kg mass. This is given. Are kept on a horizontal surface tied with the ends of a light string. Means these two are tied with a massless string is telling. Massless one wire we have tied to these two. A horizontal force F that is equal to 600 Newton is applied to number 1 A and number 2 B. Means what is telling, this much of force is acting on this once that force is applied toward this side. And second time the same force is applied once on B. So once on A and once on B, you have applied that much force. So in the two cases, what is the tension in this string? What is the tension in this string? That is the question here. Say, let us take the first one. First case I am taking for the first one. That means, let us say in this case, F is equal to 600 Newton is applied on this A, because of which this entire system, let us say, is moving in this direction with an acceleration A. Let here a tension is developed in the string, say that is T is the tension developed in the string. Okay, now in this case we can say that if you take a free body diagram, for the free body diagram for this, if you take on this body in this direction, one F is equal to 600 force is acting. In that direction, let us say T is the tension is acting. By that block, a T tension is acting. Finally, this block is moving in this direction with an acceleration, say that is A. Therefore, which is greater in these two means this is greater because it is moving this side. So I can write here F minus T is equals to M. Suppose say mass of this is, say this is MA. Say the mass of the block is, say that is MA. So MA into acceleration A. So net force is how much? Mass into acceleration is called net force. What is the net force on it is this one minus that one. Why? Because this is moving in this direction. So this minus that will give the net force acting on it and it is moving in this direction. That net force is given by mass into acceleration is the net force acting. So therefore this is called 600 is given here. 600 minus T is equals to MA. MA means how much? Mass of the first one is 10. So this is 10 into A. Say this as equation 1. Now in this case again, here now I will see the second body, free body diagram. On this B, say mass of B is MB. In this direction there is no force. Only the force is acting toward this side. Say that is T. This T is due to this. This is pulling this body with this much of tension. And this body is moving in this direction with an acceleration. Say that is G. So therefore, because of this tension, this force, the body is moving in this direction. So I can write here T is equals to how much that is MB into acceleration A. So this is nothing but this much of force is acting on it to move this side. So therefore here tension T is equals to MB means how much? That is given 20. So 20 into acceleration, say that is A. A we don't know. Okay. Say this as equation 2. So therefore, now we will solve these two. If you solve these two, we will get the acceleration. Suppose say 600 minus T is equals to 10A. This is T is equals to 20A. These two equations I have written here. So I can say here solving equation 1 and 2. Solving equation 1 and 2. These two will get cancelled. What is left here? 600 is equals to. This will become how much? 30A. If you add up, therefore these two will get cancelled 0, 0. Therefore, this will get cancelled by 20 times. Therefore, A is equals to 20 meter per second square. So this is the acceleration I am getting. So finally, I have calculated the acceleration. Now we have to calculate the tension in it. Tension can be calculated with this formula. Therefore, tension in this case is T is equals to M D into A. This formula we have T is equal to this much. That means 20 into A. That means 20 into A. A is also 20. Means that is 400 Newton. So here the tension in the string is 400 Newton. When a force is applied across A, that means when a force is applied across A, then the tension in the string is given by 400 Newton. So this was for the first case. Now let us see if the force is applied on a B. That said, now what is the tension? Let us see again. Now here, these are the two bodies. Now he is telling in the second case, a force is applied this much, that is F is equals to 600 Newton is applied on a body B second time. Now let us see if this system is moving in this direction with an acceleration A. Now I will again, as previously, we can take a free body diagram. So let us say the first free body diagram I will take for B. That is, if I take for B, this is mass of B body. In this direction, let us say F is equal to 600 Newton is acting. In this direction, attention T is acting, and the system is moving in toward this side with an acceleration A, suppose. Therefore, since which force is greater? Force is greater than P. Here F is greater than P, because of which the body is moving toward that side with this is greater. Therefore, the net force is given by F minus T. F minus T is equals to mv into acceleration. Mass into acceleration will give the net force acting on it, which is nothing but the difference of these two. Therefore, what is F here? 600 minus T is equals to mv means how much? 20. Therefore, 20 into A. Say this as equation 1. Now I will write the free body diagram for this. So this is the mass A body. On this A, attention A is acting. That is, attention T is acting. This is the tension acting by this B body toward this side. So now due to this tension, the A body is moving toward this side with an acceleration A. So here, therefore, tension T is equals to, in a string, mass of a body A into its acceleration A. Therefore, what is mass of acceleration? We can say mass of acceleration is nothing but 10. So I can say here 10 into A. This is called T. Say this as equation 2. Again, I will solve these two. As like we have done previously, we can solve these two. Therefore, solving equation 1 and 2, we get first equation is 600 minus T is equals to 20A. This is T is equals to 10A. These two will get cancelled. Therefore, this will become 600 is equals to, this is how much? 30A. Therefore, these two will get cancelled again. Therefore, the A is how much here? A is equals to again 20 meter per second square. So again, I got acceleration as the same. Means if you pull the body in this direction or if you pull the body in that direction with the same force, either that side or this side, with same force if you act, then the acceleration will be same. That is 20 meters per second. Now see what is the tension. Now from this equation 2, tension T is equals to 10 into A, that is 10 into, this is 20, that is 200 Newton. So when you apply a force on B, now the tension in the string is how much? 200. The same if you apply the tension at A, then the tension how much we got? That is 400. So in this case it is 200. So this is how we can calculate the tension or acceleration of this string. Okay. So thank you everyone. So remaining whatever the topic is there, we will learn in a next session. Okay. Thank you.